Does everyone hear me okay? Yeah. Cool. So how to spoof 97% of email accounts. This came out of a bit of research we were doing. Originally, it started off as we were very interested in setting our own phishing infrastructure up. We used SendGrid because SendGrid just allows you to act as an open relay and is very, very trusted. And sort of noticed there was a few abnormalities in things like SPF records and other email securities that were causing problems. So we dug a bit deeper and discovered that pretty much everyone, mainly the UK government, the US government, the FTSE 100, and 97% of everyone in the world is vulnerable to email spoofing. So when I say email spoofing, I don't mean necessarily your internal email will receive viruses or other malicious content, but you can essentially just pretend to be most people on the internet via email address. And considering most people think that this problem has been fixed when it hasn't, including many cybersecurity professionals, was a pretty good day. In fact, no one has actually fixed this yet. So we built a bunch of tools too, so you can just go on, set them up and just pretend to be a bunch of people like your boss or something at work. It's weirdly effective. In fact, there's been a few times when we've come out as even higher scored than legitimate emails. And I just wanted to start by just telling everyone how email works. So email is essentially like sending a letter. You kind of have your letter at the beginning, not standing in the way, am I? So you have your letter that you write names down to who you're sending it to, who you're sending it from, and then you put it in an envelope. Pretty easy. On that envelope, you put a secondary address, exactly like you would with a formal letter. You would say, I'm going to send this to this person, it's from this person, and when you actually have an envelope, you package it up. You add a few different things on as well. And there's a really important thing here that I will talk about in the future. If there's one thing you can take away from this, notice that there is two different email addresses or two different from addresses. There's a return path address, which is the envelope address, and there is a from address, which is the contents address. This is pretty much where the flaws in email lie. So email continues its journey. You've taken the letter, you've packaged it in an envelope. You send it to your own email server or your sending server. Your sending server will deliver that to the receiving server, which will be someone like Gmail or Microsoft. They will unpackage that email. Basically, for all intents and purposes, throw away that content. It's not thrown away, but it's in the weeds and you have to go and look at the original email header. But who actually does that, especially people aren't cyber people. And then it delivers it, unpackages it, and has that content. And this is the really important bit I want people to sort of remember. So there was a technology, because it was actually quite easy to just talk to that email server and pretend to be everyone. And since we all trust email, which we shouldn't, it's very easy to pretend to be other people. So if email didn't work, how would you know who you're actually getting emails from? It would just completely confuse the situation. So this thing called sender policy framework was invented that was supposed to verify that if I was sending from Microsoft.com or I was sending from Google.com, that I actually owned that domain and I actually had an account on that domain. And it worked like this. So we have the original, which is just your email, your normal letter, and it had a from address on it. You would package it in an envelope. You would put on another address, which remember has that secondary return path from on. You would send it to your server. Your server would forward it to the receiving server. Now this is where SPF kicks in. What would happen is it would take that envelope, it would read the domain, in this case, example.com, which is highlighted in green there, and it would do a DNS request. So it would contact a DNS server and it would look up a specific record on the internet in TXT record, and it would have an IP address. And what it would do is it would verify that these two IP addresses are the same. This is, you have a domain that you own and you say you're allowed to send from this particular IP address or send emails from this particular IP address. And the email I actually received came from that IP address, which kind of makes sense, because if I have an email server, I don't want emails from my company or my organization coming from other people's organizations or other people's servers. And then once that was approved, it would get unpackaged. They kind of throw away this stuff and deliver the letter. But the important thing again is that these two email addresses are different. So the next question I always say with people is, do these addresses have to match? Do they have to be from the same organization? Nope, Not at all, not a chance, doesn't matter. So how SPF doesn't work. So again, we have the same email originally, our nice little letter. We put it in an envelope, but this time we put a different return path address on. Now, the important point here is that I own evil.org. I bought that domain, that's my domain. So I give it to my sending server, send the email to the receiving server. The receiving server takes that envelope address, looks up that domain on the envelope address, looks up it on DNS, finds this record for my IP address because I control it, says, great, SPF passed, unpackages it and throws the guff away and then delivers the original contents with the fake email address in, which I thought was amazing. Although the one thing I will say with SPF is that there is at least an indication that something's a bit off. Not that anyone listens, but if you are forensically investigating it, you should see something happen. Or if you're good enough at looking through email headers, which we all are, I wouldn't say it's very easy, but you can tell. Now, does anyone here work for marketing? Because I'm just going to slate you right now. The worst people ever that cause this problem are marketing people. Because when they have things like MailChimp and they go, oh, we just wanted to send it from that server, or we want HR to come from HR at my own address. And that basically just makes pretty much everyone vulnerable. So how DKIM works. Now, DKIM is I think it's domain key integrity message. So if I could say that it was the most pointless security technology invented, DKIM would be the most pointless thing that's ever invented. It was supposed to, sort of back in the day, if your email got intercepted by a third party, it would essentially sign the address, it wouldn't encrypt it, but it would sign it to make sure that the contents hasn't changed since when you've sent the email. And there's two sort of really silly ways that this can be broken, but this is generally how it works. It's very similar to SPF. What you would have is you'd have your original letter, package it in an envelope again. And this time you would also have those original delivered to and return path addresses. We would have a bunch of these values here. So these values here, sort of the S, the B, and the BH, are just like cryptographic signatures. They're checks that you can't defeat easily to be able to verify that this contents is 100% legitimate. But what you would do is you would send that email on. The receiving server would receive the email, take that envelope, look at the example.org again, do a DNS request. This time it would do what's called a selector. So it would put in the selector and it would check to see if there is a DNS request that exists for this particular selector. Now, the really important thing that people should understand here is that this selector here and this selector here are specified in the email address you're sending. So if you send an email without the selector or the selector's wrong, there is no way for the receiving email server to control it. Now, if you're the person or the attacker that's sending malicious emails to people or fake emails, you just don't include it, and for all intents and purposes, it doesn't exist. I will get into that though. But if this check passes, again, unpackage it, throw away the guff, and you get that original email from that original person. So how DKIM doesn't work. So this, it doesn't even do the thing it was supposed to do originally, which I just find crazy. So you would have your letter, again, package it in the envelope. You would add your nice little signature. And people love to use DKIM because they're like, oh, it's cryptography, right? Cryptography is amazing. You would have this selector that I mentioned before, which the attacker can choose not to include or just not include the entire header. Or if you are a legitimate sender, you can send it, it gets intercepted, the attacker goes, I'll just remove it. Sends it onto the server, doesn't do a DKIM check, gets free. So DKIM doesn't even do the thing which it was supposed to do, which is this. Kind of annoys me. The secondary way that you can actually get a DKIM pass, and remember the one thing I really want to make the point, is every time you get a pass for one of these security technologies, even though they're very easy to defeat, email providers go, oh, that's obviously legitimate, because for some reason people trust these things, which means that my emails get delivered very easily. So again, take the email, package the email in the envelope, add on this guff, but the important bit, again, I've given it my domain and the return address. Send it on, receiving email server gets it, takes the envelope, looks up that address, looks on the DNS server, looks at my selector, gets my public key or my value, which is in the DNS record, verifies it using those selector and these details, passes because I control everything, delivers the email, throws away the guff, and it's the original contents. So, exploiting email. SPF and DKIM have performed at the same time, and one of the things I wanted to say is that you've got those two addresses. When those two addresses match, the from address in the actual contents and the from address in the envelope, it means they're aligned. If they're not aligned, they're called misaligned or unaligned. So generally, email works this way. It will do an SPF check, which you can bypass. It will do a DKIM check, which you can bypass. It will do a DMARC alignment contents from address, which sounds like DMARC is like a domain message authentication something and something. I can't remember what it says. But basically, people kind of look at DMARC as like a conformance thing. DMARC is the most important protection for email. And 97% of people have it configured badly. And then there's another technological arc, which is authenticated receiver chain. I didn't really want to go into the detail here because I've had a few too many diagrams. But sometimes email doesn't just go through two servers. If you're using someone like MailChimp or you're sending it through someone like Azure, what might happen is it might go through multiple different emails. Now, what Arc does is it checks at each point that at the beginning, when it hits your email server, it's performed the SPF and the DKIM check and the DMARC check. And then when it gets sent over to the next server, it just takes the value from the last server and checks that it performed it while it performs its own checks. Now, this sounds a bit of a mouthful, but basically what it allows you to do is in the email headers, you can basically trick Google into signing your completely fake address. So when someone forensically looks at it, you've got a bunch of fake data, which has been approved by Google. Now, it's an experimental standard Arc, so I didn't want to go into it too much, but it's really good for making your completely illegitimate emails look even more legitimate from the perspective of a forensic expert. In fact, I was doing this to my own red team members and it worked for me in a meeting at work where I was just sending them like approvals that just didn't even exist in my own company because it was funny. So if you have a missing DMARC record, you will be spoofed. If you have bad spelling and misconfiguration, it is very easy to misconfigure DMARC. It will be success. Now these values, so this next value, P, or the primary domain or the policy value, is essentially a way for you to tell other people how to treat fake emails. So you can either reject the email outright, which it doesn't get through to spam, it doesn't even get through to the inbox, or it shouldn't. If you have quarantine, it should just put it in the spam folder. If you have none, it means we explicitly permit spoof emails. People that have DMARC records configured, 99% of them use this value, which is none. There's another one as well, so you can work for subdomains. So subdomains is obviously hr.example.org. You can actually have two different policies set. So you might not be able to send something on the primary domain, but for the subdomain, Ministry of Defense, it's very easy to spoof a huge amount of people on that network. And this is something that a lot of the UK government, mainly the Ministry of Defence, the NHS, suffer from. So if that value is set to none, then your emails will get through. And perhaps my favorite, and I have no idea why this isn't a standard. So % tells you how many emails you should check. So how many spoof emails you should reject. A lot of companies have 0% for checking emails set in their % value. Now, what this means is that we want to apply our policy of quarantine bad emails 0% of the time. So if it's 0, it's saying, we want you to quarantine them, but we want you to 100% ignore it. It only works for quarantine. What it does, it like knocks the value down. So if your original email was at reject, it would knock it down to quarantine. If it's at quarantine, then it would knock it down to none, which is essentially, we now permit spoof emails. This whole idea behind these, I could see where it comes from. It was, if you wanted to implement security of your organization, you didn't want to block every single marketing email going out. It's a bad idea. The marketing department would get really upset with you. So what you would do is you like gradually introduce it and see the problems. Apart from people set it up 10 years ago and just never bothered doing anything else, which is good for me, right? So we built a tool called DMARC Checker. DMARC Checker will, I think it processes like 500 domains a second. So I ran like the top 1,000,000 domains through it. I wrote it in Rust. What it will do is it will just go through and give you an indication of which domains are vulnerable. So we did this against, I think these here, we've sorted it for, oh, what's this? This is the UK government. And I think it was 80% of UK government domains are vulnerable. So you can see here on the right-hand column, all of these here are explicitly permit spoof emails. MI5 suffer from this, the CIA suffer from it, National Crime Agency suffer from it, the Met Police suffer from it. Unfortunately, NCSC and GCHQ and the NSA don't, which annoyed me because that would have been funny. We also built a tool called Mail Spoofer. Now, Mail Spoofer, and I do have a demo on my laptop if people want to see it later. Mail Spoofer basically just does all of this stuff in the background. We have it just sets up an email server. It sets up the DKIM record automatically. We use Cloudflare API, so it's like as close to a one-click solution I can give you. I have a YouTube video where I go through it quite slowly with people and just spoof emails live because it's funny. And it basically just does everything for you, and then it'll just set up a page and you can just send spoof emails to people. But if you want to go and download it and just spoof your boss or anyone, it's quite fun to play with. And this is kind of what it looks like. You have a bunch of sending profiles. So we use GoFish in the background with Mail Spoofer. I mean, there's no point reinventing the wheel. So we just combined a bunch of different technologies in a clever way to exploit some stuff. And some of these are the emails that we got through. So this was Cisco. I sent them to Gmail. Now, Gmail is actually quite interesting because if the messages don't align, they still allow the email through, but they put via on it. So I set up a domain called iCheck, which is like, sounded like integrity check. So instead of me needing to buy a domain that looks like Cisco, I just spoofed Cisco directly. Anyone in Cisco, I just used no reply because I didn't want to call anyone out. And then it just says via iCheck in Google. All of these 100% got through to the email inbox. Absolutely no spam things were triggered. I think this one in the middle, I think it's AOL, and the last one is Yahoo, but I can't remember which one round is. The really good thing about Yahoo as well is when I'm sending my fake emails, it actually looks up the domain for me and adds in a little Cisco logo, which is their actual legitimate logo. So I look even more legitimate. So there you go. So here's these addresses. This is what it looks like. So this is a header. This was in Gmail. So all of these are fake. So this email address was sent to my work account from IRM PLC, which is a pen testing company. Don't take this badly. You're all terrible. There's only one company that I was messing around with. And what happens is within DMARC, you can specify an email address that says, if we've noticed any spoofs or any weird things going on email, they will send an email to their internal team. And there's the only company that internal team actually fixed it. And that company is a very big cybersecurity company that is quite close to me, so people can probably figure that out. But fair play for them to noticing their bad email configuration and fixing it. But the best bit is I was actually sending it to like my actual work email address, so they know that I know who they are, and was just messing with them for a few days, which kind of makes me happy. But this is what it looks like. So you can clearly see there's an SPF pass, there's a DKIM pass, because it doesn't actually cover the contents address. And when it gets delivered to the end user only sees the contents address. All these technologies are only performed against the return address. Sorry, the return address or return path address. So again, this is a completely fake email. And this is kind of what it looks like. I apologize if this is a bit small. I tried to make it as big as I could. So here, within my authentication results on Gmail, I have a DKIM pass, an ARC pass, and an SPS pass. And each one of these things says, this looks really good. You've had a positive indication. The ARC pass as well. So this is the bit where, so this record in red here was, I rewrote some Lua scripts on our server. And what it did is it actually, all this is completely fake. So this ARC pass here, where it says pass, this means that Google have received that, signed it and said, oh, you've passed. And if you don't know what ARC is, which most people don't, and you're just looking through to see if there are actually checks on here, forensically, most people, I believe, would go through and say, oh, well, that's a legitimate email. It's from the correct address. The domain spelling is correct. It's got its DKIM, its ARC pass, its SPF pass, and it's got some stuff in here. And this stuff in here, I've actually said a DMARC pass. I can't, unless you own the domain, I can't forge a DMARC pass. but I can forge everything else and then put a fake header in there, which is then signed by Google as a legitimate thing. And if you don't know all of these nuances, it can go very badly wrong. So again, so this is the ARC authentication results, and these are all the illegitimate ones. And all of this stuff here is the stuff which is actually completely illegitimate. And there you go. There's my little DMARC pass, which I've completely forged entirely and doesn't actually exist. But if you were just typing in Control F, looking for DMARC, and it says passed, you'd say, oh, well, this email's legitimate. The good thing is computers as well also accept as legitimate. So I did this for a private government group of only cybersecurity people. I think like 90% of them are vulnerable. So this is me just sending the emails proving that they were vulnerable. Here's my favorite bit. So we actually ran this through to see how legitimate our emails looked. And there was a website that's called Mail Tester. And what it does is, I imagine you know what it is if you're doing that, sorry. But what you would do is you would send an email to it, and it would do a bunch of checks in the back end, and it would say how legitimate it looks, whether or not it's going to get blocked by spam. I managed to get 9.9 out of 10, which is actually better than the original email, which is 7. So I'm actually more legitimate than legitimate emails. So people would actually prefer to throw away the legitimate emails for my fake emails. And when I said this is literally your user, this is your boss, this is your CEO, this is the director of the CIA, this is the director of MI5. All of them get through. So we did some scans. 70% of FTSE 100 companies are vulnerable to this. 80% of the UK government, 85% of the US government, so we win. And 97 to 99% of the top 1 million domains. And this is very, very skewed heavily in the favor of companies that know what they're doing. So all the FANG companies know what they're doing. So your Facebook, your Amazons, your Netflix. But the interesting thing with these companies as well is they have a lot of subdomains. And you need to do this if you want to have individual configurations. You have a lot of organizations. You need to go through and check all of them. In fact, this is actually, if you really wanted to fix this, all you do is you add one domain record with 2 words, and it makes the whole problem go away. If you are a large organization that does do a lot of marketing and uses third-party senders, you have the potential to blocking all of your email addresses, all of your outbound email. So work through it carefully. But if you're a small organization and want to make this problem go away, write 2 words down in a box on the internet and it goes away. Anyway, that was my very quick whirlwind tour through why email security is awful.